I am Ennemcien. Our next AC circuit is combination of resistance and capacitance. Resistance, capacitance. This combination is connected to an AC source supplying an AC voltage of RMS value V. A voltage VR is developed across R, VC across the capacitance. We have seen that current and voltage are in the same phase in resistance, whereas current leads on voltage by 90 degree in a capacitor. So we can draw the vector diagram and solve the problem easily. This is the baseline in which the current vector is imagined to be present. Since resistance is an in-phase element, VR must be in phase with current, that is, this vector must be drawn on the same line. Voltage in capacitor, current leads, that means voltage lags behind the current. Lagging quantity must be drawn downward below the baseline. So since the phase difference is 90 degree between voltage and current in capacitor, VC must be drawn at 90 degree in the downward direction. In RL circuit, VL was drawn upward, making 90 degree with the baseline. It is downward. The two make a total of V given by parallelogram law. We can write as in LR circuit, V square equals VR square plus VC square. That is, V square is V is IZ, where Z is the total impedance of the circuit. So I square Z square equals VR square is I square R square plus VC square is I square XC square, where XC is 1 by omega C. I square would go, then we will get Z equals square root of R square plus XC square, or Z equals square root of R square plus 1 by omega square C square. This is the total impedance formula for RC circuit. From the same, now here what is the net result? Applied voltage or total voltage lags behind current because it is the total voltage vector is below the baseline. That means, or current line, that means applied voltage lags behind current by a phase of phi, given by tan phi equals this by this, or VC by VR. That is, tan phi equals VC by R. VC is I into XC, or I into 1 by omega C, by VR is I into R. Or we get 1 by omega C by R, or tan phi equals 1 by omega C R. Or phi is tan inverse 1 by omega C R. This is the impedance triangle. This is R. 1 by omega C is at 90 degree. Z is the hypotenuse. So you get Z square equals R square plus 1 by omega square C square. Now the instantaneous values of the equation. V equals V0 sin omega t. If this is the given applied voltage, then the net current, here current is leading or voltage is lagging, that means current is leading the voltage by phi. So current equation must be I equals I0 sin omega t plus phi. This is the RC circuit. We will discuss the power consumed by the circuit after completing this circuit. We have one more circuit other two more circuits. The next is very important, that is series combination of all these three: inductance coil, capacitor, resistor. Applied AC voltage has an RMS value V volt. Voltage across coil is VL, VC, VR. You can draw the vector diagram. Baseline or current line is horizontal. Then VR must be on the same line because resistance is an in-phase element. VL leads on the current by 90 degrees. So VL must be drawn up, OB. VC lags behind the current by 90 degree. So it must be drawn like this. These two vectors are opposites. So resultant of these two is VL minus VC or VC minus VL, whichever is greater. That depends. Here it is shown to be VL is greater than VC. So the resultant of these two give VL minus VC, that is up. Then VR. Final resultant is V. So you use Pythagoras theorem. V square equals VR square plus this square, or VL minus VC the whole square. You put V equals IZ, IR, IXL or I omega L, I into XC or I into 1 by omega C. Yeah, common factor I would go, then you will get Z square equals R square plus omega L minus 1 by omega C the whole square. This is the formula for the total impedance of the circuit. And this is the impedance triangle. R, this is omega L minus 1 by omega C, and this is Z, total impedance. This triangle will obey this equation, Pythagoras theorem. Phase, here the voltage resultant or applied voltage leads on current by the phase phi, which can be found out as tan phi equals omega L minus 1 by omega C divided by R. Now we have to discuss this special circuit in somewhat detail. So I postpone that discussion to another posting. Thank you.